everyone. My name is Anjali Dahiya. First of all, let me thank you all for joining this webinar today. My presentation is particularly relevant to those of you who are curious about industrial robotics and its a different purpose in industry. So my presentation is a structure-based introduction of these robots, their types, their components and grippers, and also programming of these robots. Starting from the introduction, industrial robots are programmed robots and they can move in three dimensions. They are used for performing the tasks which are difficult and dangerous for humans. They play a vital role in manufacturing industry and due to their durability and flexibility, they are ideal for industrial purpose. So the robotics involves different fields, designing, building, manufacturing and operations. So this is the general asked question that why we use robots. And one of the best thing about robots is their ability to do the tasks which are repetitive and boring and that are dangerous for a human. Let me tell you some examples of uses of robots in manufacturing. So we all know that welding is a very important part in manufacturing environment, but unfortunately, a single moment of unintention can spell a disaster for a human welder. So it requires a skilled worker, but sometimes the mistakes can cause a lot of waste in terms of resources and as well as time. So with the help of robots, this can be eliminated like noise and also heat which generates throughout the process. So there are some applications of industrial robots which include R&D and in this application the robot helps the workers in the safety of the arc and the inhabiting hazardous lands. And the second is sport welding. So in this, it joins the two contacting metal surfaces by directing a large current through the sport, which melts the metal and then forms the weld delivered to the sport in a very short time. And this is also used in material handling for transferring the objects from one point to the another point. And it is also used in painting operations for increasing the quality and consistency of the product. So there are some components which are used in the robot. So these are link. So the link is a rigid member which connects the two joints. You can see in this video that the link can be defined by the distance between the two joints in x direction. So let me show you this. For the joint 1, you can see that here is the movement in x direction from joint 1 to joint 2. The second thing is joints. So joints are the movable components that causes the relative motion between the two adjacent links. And mostly the industrial robots include 3 to 6 joints or axes. So there are some types of joints like a revolute joint, prismatic joint, helical joint, spherical joint, and cylindrical joint. The next thing is degree of freedom. So it is defined by the motion capabilities of robots. So it says that in how many directions a robot can freely move. So how so there are more axes a robot allows. So it may have the greater amount of work envelope. You can see the degree of freedom star robot figure. So this is the first joint, this is the second joint, this is the third joint. All three are the rotational joint, and this is the prismatic joint. So it can move in 360 degrees, the same rotation, and the last one, which is a prismatic joint, can only move in upward and downward direction. The last one is the manipulator. So manipulator is like a structure of an industrial robot. So it is responsible for completing the task which is assigned to this robot. And it is mounted to the robot body and it consists of multiple links and joints. You can see different parts of this manipulator, which include joints, links, door arms, motor, base, and base. Now, there are different types of industrial robots used in the industry and they are on the basis of their applications. So, You can see there are Cartesian robots, star robots, articulated robots, delta robots, cylindrical, polar, and copods. So the first one is the Cartesian robot. So this is also known as linear or geometry robot. So it works on the three direction in the straight line, in the X, Y, and Z direction. And this is often used in CNC machines and 3D printing operations. Second one is SCARA robot. It is the abbreviation of Selective Compliance Assembly Robot Arm, and it functions in three axes X, Y, and Z, and it provides the rotation movement. And also due to their small size, it is used for assembly and palletizing operations. The next one is a cylindrical robot. So a cylindrical robot is that type of robot in which it provides the rotation and the movement in upward and downward direction at the base. Delta robot. So you can see in the figure that all three arms are connected to the base. So that's why it forms a dome shape and can move both delicately and precisely in high speed due to each joint of the end effector being directly controlled by all three arms. And this is used in pick and place applications in the food, pharmaceutical, and electronic industry. The next one is the collaborative robot. So collaborative robots work in assistance with the humans. So they are typically used for pick and place operations and for quality inspection and machine tending. Now the new thing is the end effector, which is attached to the robot rest. Most of the end effectors are mechanical or electromechanical, and they perform two types of functions: to holding any object or to do the work with the object. So this is required for robotic simulation. Without the end effector, robots would be quite useless, and piece of the robot that interacts with the part or component in the environment. So sometimes they are also referred as end of arm tooling and manipulators, and they are found at the end of the robot arm. So you can see for the example, the first figure where end effector senses any metal object using the magnetic field. And in the second figure, you can see a mechanical device which is used to hold any object. So there are different types of end effectors based on their design, construction, and application. So these are grippers, sensors, and processing. So gripper is similar to a human hand. They are positioned at the end of the arm. A gripper can be attached to a robot, or it can be a part of a fixed automation system. In the simplest term, grippers are the devices that enable the robot to pick up and hold any object. When it is combined with a collaborative robot, or also known as the cobot arm, grippers enable manufacturers to automate key processes such as inspection, and they can provide the ability to the robot to pick up and move any object. So there are some applications of this gripper is that can be used in pick and place and machine tending operations. So here are different types of grippers available to use, and some grippers designs are just like human hands, which are has the five fingers, but it's not always the same thing. There are grippers with two or three fingers. So the different types of mechanical grippers are there. That vacuum grippers are there, magnetic grippers are there, servo grippers are there. Like vacuum grippers uses the suction cup to grab and hold anything, but the magnetic grippers uses the magnetic field to hold the paramagnetic items such as steel pads. The next thing is sensors. Sensors are the essential components of robotic systems. So it provides the robot with the ability to gain a perception of their environment. Sensors gather the data about the robot surroundings, which includes the position and the orientation of objects around it, and the robot itself. The robot control system then uses this information to decide how to interact with the environment. So Also, there are some types of sensors which are available in the market. First one is the proximity sensor. So, proximity sensors are used to detect the presence or absence of any object with the help of End Effector. Second one is the force and the torque sensor. So, force and torque sensor measure the amount of force or torque which is being applied to the robot. And also, light sensors can detect the presence or absence of any light, and it is used to provide feedback on the position of objects in low light environments. The next one is the process tools. So, process tools in the robot and effector are attachment or devices which is used to perform the specific task. It works in coordination with the robotic arm, and it provides additional functionalities to the robot. It can be as simple as driver, but also it can be as complex as the whole robot. You can see in the figure where it performs doing any object. The next thing is applications of the End Effector. So you can see that there are wide range of the applications of these End Effectors which play a vital role in all industries which employs the robot. First one is the manufacturing industry. So it is used in manufacturing applications for doing any pick and place tasks, and it increases the productivity and efficiency. It also used for welding operations and machine handling. The second one is the food and beverage industry. It is used in this industry to automate tasks, which is sorting and palletizing. It handles the fragile and perishable items with very care, and it can be designed to meet strict hygiene standards. The next one is agriculture. It is used for tasks which is harvesting, planting, and crop maintenance. It can be equipped with sensors to detect the ripeness and crop and to monitor soil conditions. In the automotive industry, it is used to handle various components such as engines, transmissions, and wheels. It can also perform tasks such as